What's going on, everyone? In today's discussion, let's go over implicit differentiation, okay? And so implicit differentiation is a little bit different from how we've been calculating derivatives previously, right? And basically it means that we can evaluate our derivatives, right, our math equations, without having it in this y is equal to f of x form, okay? And what I mean by that is, thus far, all of the functions that we've seen really come in this form, right? Something like f of x is equal to 3x plus 2, right? Where we said that we can also write y is equal to 3x plus 2, right? Because these two equations are the same, because y is typically a function of x, all right? And so when we were finding the derivative with respect to x, right, of our function f of x, we just wrote it like this: d over dx, right, of the entire right-hand side, right, and then we would distribute our derivatives. So it would become the derivative of 3x plus the derivative of 2. All right, that's what we did before. Today, we are able to just go straight from our equation, right? Say I give you this equation: x squared plus y squared is equal to 25, right? So say I give you this equation, and I want you to find the derivative dy dx, okay? This is your equation. This is what you're trying to find. And so in implicit differentiation, you don't have to simplify, right, and solve it to where it's going to be y is equal to stuff on the right-hand side, okay? We're going to take it straight from here, but in doing so, we are going to abide by an assumption, right, that even though we don't have to, right, put our equation in the y is equal to f of x format, we are still going to recognize that y is a function of x, all right? And this is just like the formal way of saying that you might see. Y is an implicitly differentiable function of x. That just means that even though we didn't solve, or we didn't put our math equation in terms of y is equal to stuff on the right-hand side, right, we're still going to recognize that y is a function of x. And because of this, whenever you go to take the derivative of y, right, the derivative with respect to y, we are going to have to consider the chain rule, all right? And remember, the chain rule from what we talked about was where if we wanted to find the derivative with respect to x, right, of some function f of g of x, right, we said that we would first find the derivative of our entire function multiplied by just the derivative with respect to x of the stuff on the inside, right? And we said that, for example, if we were finding the derivative with respect to x of cosine of 2x, right, the derivative of our entire function in this case was cosine of 2x. And so we know that by definition, the derivative of cosine of the stuff inside is going to be equal to negative sine, right, of the stuff inside. Leave it alone. Now you're going to multiply this by the derivative of just the stuff on the inside. So just the derivative of 2x, right, which in this case is just 2, if you use the power rule. And we said that when you multiply together, you get negative 2 sine of 2x, okay? And so in our case today, when we talk about, right, dy over dx, right, because that's what I'm asking for, dy over dx, right, you're going to remember that this can be calculated by d over dy, right, the derivative of whatever your term is, multiplied by dy over dx, right? And this is how we are actually going to solve for dy dx, right? This term using implicit differentiation. And we're going to go over that right now in this example. Okay? And so let's do that. Let's look at x squared plus y squared is equal to 25, right? And so we're trying to find the derivative. We're just going to go straight for the gusto, right? So we're just going to take the derivative with respect to x of both sides. So everything on the left-hand side, right, equals the derivative of everything on the right-hand side. And there's no particular reason why I'm using square brackets. I just happen to. Okay. And so we know that in this case, you're still going to distribute, right, your derivative to each term in your expression. So this is the same thing as d over dx, or the derivative with respect to x, right, of x squared plus the derivative with respect to x of y squared is equal to the derivative with respect to x of 25. And I'm going to keep these in the d over dx of whatever form until we solve all of them together. That way we can keep up, okay? And so this term and this term are going to stay, they're pretty simple, right? Because this, you can use the power rule. And here, you know, the derivative of a constant, a number, is just 0, right? So we know those. Let's just keep it organized though so we can see what's going on, okay? First term is the same. Now, this is where our assumption, right, that y is a function of x, right? This is where this is going to come into play. And so just think of this, right, as the chain rule. And so it's going to look like this. And I'm going to do this just so you can see. Okay. So this is going to be plus, okay, plus the derivative of the entire thing. Here we go. Derivative of the entire thing, just so we can really get the chain rule across, multiplied by the derivative of what's on the inside, right? Conceptually, that's how we talked about the chain rule. And we're going to set all this equal to the right-hand side, okay? Just to keep it organized. And so let's look at these two terms, okay? The derivative of the entire thing, right? We said that dy over dx can also be defined by d over dy times dy over dx. And so we know that y is a function of x, and so this can be simplified as the following. The derivative of y squared, right, is going to be the d over dy, that's this term, okay, of y squared. So you can think of this as the derivative of your entire term. Now we're going to consider that y is a function of x, because we're going to multiply this by differentiating y with respect to x, okay? And this is where this term comes into play, okay? And we said that this is actually the term that we're trying to solve for, is this term right here, okay? So at this point, let's bring these two terms down, right? D over dx, x squared, plus, and then equals this right-hand side. So now let's evaluate our derivatives, okay? Using the power rule, right? Exponent multiplied by your current coefficient, which is just 1 here, right? Because 1x squared is equal to x squared, same thing. 2 times 1 is your new coefficient. Leave that base there. Subtract 1 from your exponent. 2 minus 1 is 1, right? X to the 1 is the same thing as x. I'm going to leave that. Plus Same thing here. You're taking the derivative with respect to y here, right? So this is still valid. Same thing, 2, your exponent, times your current coefficient is 1. 2, keep your base there. Subtract 1 from your exponent. 2 minus 1 is 1. Y to the 1, the same thing as y. I'm going to leave that there, okay? Now, that's multiplied by this entire term because this is the term that we're actually trying to find. So at this point, we're just simplifying to try to get this term by itself, okay? And we know that the derivative of a constant of a number is 0, so it's going to be 0, okay? And so let's continue this right here. We're going to move 2x to the right-hand side. 2y times dy over dx is equal to negative 2x. We're going to divide each side by 2y to get dy over dx by itself is negative 2x divided by 2y, right? Your 2's cancel out because they're the same on top and bottom. So now you're left with your answer. Dy over dx is equal to negative x over y. Okay? So again, if you're a little bit confused, right? A quick overview. Instead of having our equation, right, in this form, y is equal to your math equation, we took it straight from our equation and we took the derivative of each side, right off the bat. So derivative of the left side is equal to derivative of the right side, right? This step was where you had to consider that y was a function of x, right? So this is the term that you are interested in. And then, right, this first term and this last term over here are going to be the same. You're going to do them how you used to, right? Power rule, and then derivative of a constant is 0. When you're considering that y is a function of x, we always are going to use the chain rule, okay? And we defined that in our previous talks that the chain rule is defined as the derivative of the entire term or function you're dealing with multiplied by the stuff just on the inside, okay? We said that when we are trying to calculate dy over dx, right, because that's what we're trying to find, right, based on this equation, then you're going to remember that dy over dx can also be rewritten as the derivative with respect to y, right, of your y term multiplied by dy over dx, the term that you were looking for, okay? So we applied this right here. So dy of this whole term right here, y squared, multiplied by dy over dx, right? Which is the term you're trying to simplify for. And the reason why we can multiply by dy over dx, again, is because y is a function of x. Okay? After this, we just simplified for dy over dx by doing simple math, and that's how we got over here. Okay? So if you need a little more help with that, or if you're unclear, just pause it real quick and just give it a look, okay? And then if you're done, then I'll give you a problem to do, and then we can solve it together, okay? So let's do this one, or try your hand at this one. So I'm gonna give you this equation, x cubed plus y cubed is equal to 6xy, okay? And I want you to find dy over dx, okay? Find this given this. And then remember that it's not in this form, right? But we're gonna always remember that y is considered a function of x, right? And so when you find the derivative of this, remember to use the chain rule, right? which we defined as the derivative with respect to x of your entire term, right? Whatever term you're taking the derivative of, multiplied by the derivative of just what's on the inside. Last tip, right, is going to be that dy over dx, the term you're trying to find, can be rewritten as d over dy, right, of some term, okay? I'm going to erase that so I don't confuse anyone, multiplied by dy over dx, right? And you're going to simplify for this term right here, okay? So go ahead and pause the video and give it a try, and then we'll get back together in a second, and we'll do it together, all right? Sweet. So let's see if our answers match up, right? So again, we're using implicit differentiation, right? And so we're not going to reformat, we're just going to dive into this, okay? So the derivative of the left-hand side, x cubed plus y cubed, is equal to the derivative of the right-hand side, 6xy, okay? And remember what we learned before, right? Take a step back and look at it, right? You're going to notice the 6 is a constant. And so you can take your 6, push this thing out front, right? And now you don't have to deal with it anymore. So let's rewrite this. D over dx. Actually, in this one step, let's distribute our derivative terms, right? And let's move our constant out. So this is going to be derivative with respect to x of x cubed plus the derivative with respect to x of y cubed is going to be equal to 6, right? Your constant times the derivative of, with respect to x, of x, y, okay? Based on what we just talked about, you know that y is going to be a function of x, right? Y is going to be a function of x. And we also know this right here. I'm going to circle the parts that we're going to use, all right? And so you know that this y here is a function of x. This y here is a function of x, okay? Which means that this derivative right here looks a lot like this, right? Some function f of x multiplied by some function g of x. When you see this, what rule are you supposed to use? If you said product rule, then you're right. Okay? And here, remember, by implicit differentiation, we're going to use the chain rule. Okay? So a lot of parts coming together now, right? Making a nice little fruit salad. So again, this is an easy term, but I'm going to try to keep all this stuff in the same term so it doesn't throw anyone off. So let's move this down. Dx of x cubed. We'll simply solve that later. Okay. Now, again, here's where we consider dy over dx, right? What we're looking for being rewritten as d over dy of your y term. In this case, our y term is y cubed multiplied by dy over dx. Okay, so let's do that. Plus, right? D over dy of our current term, y cubed. This would be considered, right, the derivative of our entire term, right, multiplied by dy over dx, because y is a function of x, okay? And this is one of the terms in this example that we're going to be looking at. Is equal to, now let's do the right-hand side, 6 times product rule, okay? Product rule, if you don't remember, is f prime g plus g prime f, with f prime and g prime being the derivative of function f of x G prime is the derivative of function g of x, and f of g are just the original f of x and g of x functions. Right? And so f of x, so the derivative of x, right, multiplied by our g of x, in this case just y, plus the derivative of our g of x, which is y, multiplied by our f of x, or x. Okay. And if you're a bit confused on this, feel free to go back to the video where we talked about the product rule, okay? And so you'll notice that this term here, d over dx of y, looks like, right? It looks like this a little bit, okay? So let's solve this across, and then I'll stop once we get to a certain point, okay? So the derivative with respect to x of x cubed, power rule is just 3x squared, because 3 times 1 is 3. Leave the base, subtract 1 from your exponent, you get 2, okay? Plus this derivative, same thing, 3 times 1, leave your base, subtract 1 from your exponent. That's 3y squared times dy over dx. This is our term that we are looking for, okay? Move on to the right-hand side. 6 times, this is just 1, times y is just y, plus, right? This is going to be dy dx, dy dx, right? Times x, and I'm going to put these in parentheses so we don't miss them. All right, so let's simplify. 3x squared plus 3y squared dy dx is equal to 6y plus 6x dy dx, right? Because 6, we had to distribute it to the y and distribute it to the x dy dx term. Now let's simplify for our term of interest, right? Dy over dx. So let's just shuffle stuff around. So 3y squared dy dx. We're going to move this. We're going to subtract 3x squared from each side, and we are going to subtract 6x dy dx from each side. So let's move this to the left, minus 6x dy dx is equal to 6y. Now let's move this to the right, minus 3x squared. Factor out, right? Factor out dy dx. Now you have dy over dx times 3y squared minus 6x, right, is equal to 6y minus 3x squared. Divide this entire term to get dy dx by itself. Dy over dx is equal to 6y minus 3x squared over 3y squared minus 6x. This is your final answer, right? We solved for dy over dx, okay? So if you were able to kind of get through this example, good job. If you weren't, it's totally fine. Feel free to go back and just look back at the parts that we talked about. And if you have any questions or comments, feel free to leave them below, okay? And I'll get back to them as soon as possible.